If you saw the keynote yesterday, I'm going to go into some of the technology behind how I wrote that demo, connecting edge device, NiFi, and CDSW. And I'll show actual slides this time. If you were in my other talks or the meetup or the demo palooza, I'm going to show a couple of slides because you got to see some slides. But I will show a live demo as long as the network's still working here. That's been kind of up and down, but if the network's working, I'll show a demo. I have a device inside the podium, and it's pulling in images of the floor, I guess I have. And it'll analyze that and send that through our system. There we go. So this is going to cover both sides of the spectrum. We're going to cover the streaming part, which is the Cloudera Data Flow, and we'll cover the Cloudera Data Science Workbench, which is the other piece of this. We show a little of each so you get a flavor of them. And hopefully you like both. If you've been in any of the NiFi talks, you've probably seen these slides. We're not going to show too many of these. We're really just going to touch on MiNiFi, NiFi. Maybe I'll show a little bit of the NiFi registry. But this is the general idea. And sure, on boxes, it's pretty easy. We're getting data in really fast or sometimes slow. People still have batch data. We do some manipulation of the data and apply that to machine learning, and then everyone in the world can have access to it. That's pretty easy. What I saw was the Cloudera tool didn't really have a way to interface to these two things. These are kind of important, the jobs and the models. So what's nice is with NiFi, we can pretty much connect to any REST API very easily. So what I'm doing and what I'll show in the demo is I have a NiFi flow ingesting data, and it's going to call a model to get results back. I do a classification on an image. I also use it for sentiment analysis. You could pretty much put anything into a model. That's Python, that's R, whatever you think makes sense for a model. And that could be a pre-built model that you load within a small runner. Like that could be a pickle or a PIML or any kind of weird acronym or TensorFlow Lite. I'm doing MXNet. It could be pretty much anything. Jobs is kind of cool. This is more of a fire and forget it. This is more of a batch idea. This is, I want to send something there, have something happen. This is a nice way, yet another way for NiFi to connect to Spark. Doesn't have to be Spark. The job could be anything Python or R, but it could be PySpark. So in this one, I'm taking data from NiFi, send it to this job. It's a PySpark job. Saves it in HDFS as a Parquet file. For the little bit of data science, this is a pretty typical workflow. We're trying to make this easier with Cloudera Data Science Workbench and as well as NiFi. I put a couple points in there where NiFi is important for this. When you're trying to ingest that data, wrangle the data, whatever you want to call that, clean it up, convert it, normalize it, be able to ingest it and make it usable. And then on the other side, to make this easy to serve and to put inside applications, wherever those applications are. Do you need a REST interface? Do you need Kafka? There's a lot of different protocols, and NiFi is kind of a universal gateway, which comes in really handy when you have lots of other tools you might want to connect to down system here, and they might support only JMS, or they might only support MQTT. NiFi could sit in the middle, convert a REST call to a JMS call, or to MQTT, or anything you might need for doing what you're doing. Again, in the beginning, the Cloudera Data Science team didn't have a way to do these streaming apps. We do now. With NiFi and Kafka streams, we can connect and run machine learning and deep learning as part of this whole process. This is kind of an evolving thing. A lot of people aren't doing this. I mean, it can get, depending on what you're doing, this can be pretty difficult. We do give you the tools to do this. This is a new area where you could do a lot of this as part of a stream. If you saw the Demopalooza with George, he was showing how to use EFM to do PIML models. I'm going to show you a little on a pre-built Gluon model, which is Model Zoo for Apache MXNet for computer vision. So one of the examples is I've got images. We put them in here. NiFi ingests the images, does filters, and then could send it on to CDSW to do our analytics on there. For computer vision, there's a limited set of things you could do, but I could put it on top of OpenCV if I wanted to do simple things like, make an image black and white, resize it, those kind of things. Or this could be if this is text analytics or NLP. You get the idea. If you have any kind of machine learning or deep learning, you could put it into a model that's hosted by CDSW and very easily have that as part of your ingest pattern, whether it's batch, streaming, coming off a device, that sort of thing. What's cool is, especially for the data science people, we have support for GPUs in pretty much any place you're doing this. This also applies for our Hortonworks fans, including myself. You can support GPUs on HTTP, so you'll be able to run it and get that support. When you're creating, I'll show you the interface for CDW. When you're going through, you could pick, how many, you're creating a Docker container and you get to pick how many virtual CPUs, if you want a GPU, how much RAM, and then that gets spin up on demand on Kubernetes, which is what CDSW is running on. So to put some buzzwords in here where we're missing them. This is a walkthrough. I put this in the slide so you could reference them later. I'll show you a little bit through the live tool, but it's this easy to create a model. And once you have a model, you have a full REST API. It's got monitoring. It's got all the basic things that you might write yourself. You might do this in Flask or Dash or something else, but you're hand rolling that each time. You make sure you do it standardized. Where are you hosting that? You're spinning up your own Docker container somewhere. How are you managing those? How do you move a new model there? That kind of, how do I share that with other people in my team? That's built into the product. It makes it extremely simple to host any of these models. You have the whole data science workflow. You start working on it. You do some experiments. You get ready. You deploy a model that's shared with anyone in your organization you want to be able to manage this. What's nice is, as you can see here, we've got the specs on that. You can see your GPU, your CPU, how many cores you have. This is all packaged automatically for you in a Docker image. So that's, again, some more buzzwords that people like. It's a pretty simple interface. What you'll notice if you're coming from Jupyter or Zeppelin, this is not Jupyter or Zeppelin. This is not a notebook system. The designers of this, they thought of, we want to make something that's like GitHub. We want to make something that's developer first. This is not for people who want a full notebook. Do your work in your notebook. Push it into this environment. Now it's shared for anyone in your organization to use, look at, maybe run it, maybe extend it depending on what permissions you have. And what's nice is here, when I open a workbench, it keeps that session. So I could see what I did, see what someone else ran, see the results, and go, okay, this is what they were working on, and get an idea what I can do. It puts the files in one place, again, that GitHub style interface, which is very nice for sharing among teams. And it's not, like I said, this is not Jupyter. It does have the IPython engine under there, so it'll do that same kind of graphics and charts, and how it runs is the same, but it's not designed for you to be doing the notebook type program. This is for, I have code, I want to run it, test it, and when I'm ready, I could deploy it as a model or deploy it as an experiment. which is nice. What's nice too is while I'm doing these interactive sessions, I can install any Python or R libraries I need. And when I just figure out which ones I have, I can package them up in a shell script. And when it deploys each Docker image of my run, it will install those for you. And like I said, you could do basic display and analytics in there, charts, graphs. It's pretty straightforward, and I'm running a deep learning model here. Again, we're library agnostic. If you want to use TensorFlow, if you want to use scikit, if you want to use MXNet, PyTorch, all that's supported, all that's been tested, all that works fine. I'm kind of partial to MXNet. I have a talk today that's doing deep learning, 100% Apache, so everything is completely Apache open source. So when you get started in a workbench, it's extremely easy to do this. You're just following a very simple library. The one thing that's a little different is it's per function. So you got to wrap everything in a function. So that's really, that kind of gives it like a Lambda feel. You're running a particular function. But that means if you write one big Python script, if you're that kind of person, you could have multiple functions and have those as separate models, depending on how you want to do that. And then you get the display of how it's running. You know, it's very easy to deploy. And then you could watch it being built, and you get those are saved. So if you want to look back and how that was built, you'll see that. So if people are curious what's going on, you have all that in there. And it provides what I think is nice, besides the deploy in the Perl script, not Perl, curl or Python, and you could copy that into your code to use it. That's also very easy to grab that same URL and put it into NiFi. It also has a built-in tester, so you could test it, see the results there in place. You don't have to go to the command line to test it. And it gives you, nice formatted results. Most people are going to want to return JSON, which is a pretty standard return format from REST. And it will show you all the results in there when you're monitoring it. You can see how many calls there were there errors, and you get the full standard out and standard error if you want to watch that and see what happens when people call you. So I've connected that with NiFi, which is very straightforward. So we make those calls, and this is the data I get back. What's nice with NiFi, I can run queries on those results as they come back. So this is the result of deep learning analysis of an image. I get that back with the shape of where it is, the class of what it says it is, and what percent confidence it has. So I could take that and I can use that in a query in NiFi. So here I'm looking if it's a cat or a person, which is common in my office, do one thing. If there's no cats or people, do something else. Whatever you want to do there. And this is the same kind of thing for jobs. I'll go into this live. What's nice with jobs, it's got kind of, shows you how long things took. It keeps a history of how many calls, how many failures. Again, this is a nice way to integrate batch-style jobs with NiFi. They return back a status, and you can look at that status. It's kind of similar to what we did with Livy. So you have yet another way to call Spark. I know a lot of people want to do Spark. Now we have multiple ways to do it. You could do it through Kafka, do it through CDSW, do it through Livy. It's a nice set of integration there. Again, that's probably enough slides for me. I'm surprised I made it that long. So let's start with the simplest thing, NiFi. Inside this desk, it's not on a messy table this time, so you can't see all that mess. I fit it in the inside here. I've got a device running, reading this camera. It's ingesting data. I've let it back up a little bit, which is, I think, one of the best features of NiFi is it makes it very easy for testing, debugging, is because I could just pause it. So I paused my processing of this in the middle so I can make sure I had some data for the demo in case my device died, we ran out of network, or something weird happens. I have that data waiting in a queue, and that's a configurable queue. This is what the results are. This is the data from that sense hat. So this is all the temperature readings. Plus on that device, I have Intel TPU to accelerate deep learning. So I have deep learning running on that device. It's looking at that camera as well. And that's giving me back some of those results plus humidity, temperature. We're combining a couple different things in here. So what I'll do next is, let's start this up. And what I'm going to have here is I'm routing based on what it is. So I have a couple things running on this box. I have one that's reading the sensors and doing one of the deep learning analyses. And another one's doing it as a separate TensorFlow one. And then the third is I have that image, which I'm pulling from a list of files, and I'm sending that out to get processed in the next part. So when this comes through, I have some immediate routing I can do. Now I can move that to MiNiFi if there's some kind of local activity. Say there's something I could do on the box to handle when it's getting cold, getting too hot. I have a one device that has a fan I could turn on and off. So for a later demo, I'll probably do that. If the temperature gets too hot, trigger the fan. And I could do that locally on the device, even if the network's down. So you don't have to worry about your device dying. I put it in here so it's a little easier to see. When you're inside the device, you don't have that. You can't see what it's doing because there's no UI. And we do this on purpose because to run a full web UI on a device is probably not practical. Probably not good for security either. Says Mr. Security in the front here. So what I'm doing is a very simple SQL query. What's very cool about this is a SQL query on that data that came off a device with no schema beforehand, thanks to the upgrades in NiFi. I can just look at that data and it's figuring out what those fields are and what type they are, and to make sure I cast it. So I'm looking at the temperature field coming off of that stream of data we saw, and if it's under 85, I want to post this, and the easiest interface that I've come up with, and it's only for me, no one else seems to think this is cool, is I'd post all that image to Slack. I could push this to an email, I could push this to a messaging system or put it in a dashboard, but Slack is really easy. Everyone has Slack, and they give me a free web UI, so that's kind of nice. So as that temperature goes, it's posting it over here, and it's got, what's cool about NiFi is I have a unique ID, so if I'm capturing all that provenance data, I'll know exactly, I could pinpoint exactly, someone says, what's this 86? I have a unique ID that I could search through my provenance, find everything about it, what device that came off of, when, what are all the other parameters there. So I've got that, and if you were writing your own app, you could have a link there that went right into a detailed record, because everything NiFi does, you could pull that provenance out and store it somewhere. And that's some valuable data, maybe more valuable than your actual data. I think Andy said that like a couple hours ago, right there. Some people will have no content, and they just want the metadata. Really just to know, maybe I just want a heartbeat from that device, when it was, just its unique ID, and it's just going, I'm on, I'm on, I'm on. That could be, as you see, it's still loading there. Keep sending more messages. So we do that part, that's one part. The other part is, you saw I had some results coming back. There was those sensor readings, there was that deep learning on the device. Well, is that blurry for other people? Yeah. Can we, it's a little blurry. Is there a way to adjust that, or is that just to make errors harder to see? But what we're doing here is, oh, there you go. Oh, that's a little better. I thought maybe I was going blind, Still, I could still use NiFi though, fortunately. So what I'm doing is I'm saving those. I convert them into Avro. Thanks, Mr. Avro in the front row. And from Avro, I convert to Parquet, which is a popular format for our Cloudera folks. and also for the Spark people, and I'm saving that to an HDFS cluster. So now I have all that data while that's coming through the system. I did a real-time alert and stored it. So now I've got deep learning models running on the edge device, and then I come into NiFi, I'm ingesting data, doing routing, alerting, and then remember I said I had those images coming in. Well, I'm not throwing them away. I mean, most systems, how do you handle images? That's kind of complex to write, right? If you're working on images, you know, that's not something your ETL tools are working with, right? But that's something that's pretty trivial for NiFi to work with. So I have it coming in. I'm putting it to a couple of places. I'm putting it into Imager, which is one of the public places where you could post images for free. And I'm sending that image of that camera there. The reason I'm doing that is because my CDSW is in a protected network. And there's a couple ways for me to get images there, not a lot of good ones. So the way I've been doing is I put it into Imager, into a public thing. It could be in an S3 bucket that they both have shared information to. I also put in HDFS. I thought this was just a cool way to share an image between things in different security zones. So right now I've pushed it there and I got the URL, cleaned it up, and then from there I pass that URL to NiFi to build up a REST call. So I'm going to take a REST call, pass that URL to Data Science Workbench, and if it's running, which the network here has been pretty bad for that, what it'll do is it'll run that analytics on that image. So I point to that image, and what I'll get back is this result. It's a JSON class that has, you know, some basic information. Like I said, the percent confidence it has, what class it thinks it is, and a couple of variables I like to have in there, like how long it took to run, and some of the machine specs. What's interesting on those machine specs are, those are the specs. If you look here, one virtual CPU and 16 gig of RAM, that was the size of the Docker container I'm using to run these. And that's very configurable. You know, when I do deploys, I could show you here, I could deploy, I get a couple different sizes. And when you deploy them, you get to pick, you know, how big do I want this? Like if I want to deploy a new model, it's unreasonably simple. You know, I put in a name for it, and I pick a file. Remember that files? Those are files that I could share with my whole team. So someone else wrote it and said, Tim, this is ready. You want to try it? Let me pick, you know, one of the models you have out here. The one thing I wish they did automatically is pick the function or give you a list, but I guess you can be too much. And here they would like an example of the input. As you saw, that'll show up on that test screen. That makes it easy for people. And also, if you put a valid test in there, when you press test, it'll automatically run with that. So you can pick what kernel you want to use. And this is cool, is you can pick all the engines that your admin has set up for you. Now, in this other environment, we have a GPU on there. So when I do a new model, I could also pick how many GPUs you want. Now, if you're doing a model that's actually, say, reclassifying, you know, point this to a couple of GPUs, and you can have, as that data comes in, I could use one for getting classification results and one for retraining. You know, especially if you've got enough GPUs you can make available, you know, this could be, you know, pretty beefy. And this can point to your Cloudera or Hortonworks cluster, and, you know, you could have, you know, a lot of nodes there, a lot of GPUs, whether that's cloud or on-premise. And this is configurable, so if you don't want to give every data scientist as much space as they want, you can, because I know if I'm a data scientist, I'm going to pick the largest possible one I could get, even if I'm doing something trivial. Like I'm running sentiment analysis, that is maybe a half a CPU, 1 gig of RAM. So that's just what you could do there. Like, yeah, sentiment here, I have that in one CPU, and that's overkill, because all it does is a very simple Simple thing there. So we call that, we get our result back, we parse it, because I want to see what's coming back. Let's see if we got any results here yet. When it comes back, I get some JSON. I take that JSON. Remember I said about Spark jobs. Now, I could be done right now with that processing, or I could send a message to Kafka for maybe Spark streaming or Kafka streams to do more with it. Or that could be it with the flow. But I decided to take the results of that model call and call a job. And that job's designed to save it into a database. And again, because NiFi, I can handle every result. When it's done calling that job, I take all that job data that they give me on the status and, I committed this job or whatever, and I store that too. Just because, the more data you store, the more nodes you buy, and then I can get better close. So that would be nice. And then, again, Slack for my errors, because it's very easy to do Slack. Again, I can push this to a custom system. Do we have any errors? No errors. That's nice. I can push it to, wherever you need to put your errors. Slack is a nice one, especially if you're doing any kind of DevOps with a team. It's kind of nice. The chat ops, that people can see this. If I get an error message, send it to a Slack channel that my admins are sitting on so they don't have to get 1,000 emails. And it's very easy to push things here. I'm pushing TensorFlow results and the MXNet results there. And I'm also pushing errors. Yeah, as you can see, I guess one algorithm thinks this is a laptop, and one algorithm thinks it's a TV monitor. Those are both native NiFi processors. So again, we were talking, where can I run AI? It's running on the little box here. It's also running in NiFi in a native version. I have a Java processor for MXNet doing single shot detector. That one seems to be a little better than the TensorFlow one, which is Inception v4, and that keeps binder. So that one keeps, it doesn't seem as smart as the single shot detector. I mean, it depends what they were trained on. These are pre-built models. The angle, I don't know, maybe someone walked in front of it. The best was you put the talk the other day, you put the microphone in front of the camera and it just kept looking at that, which is great, which is nice with using this as my interface. All that stuff is still here. So here's what I was running that detector on for a while. It's this great picture of the microphone pointing at the camera, which is, I'm glad I'm not storing that somewhere of value. Let Slack, free Slack channels, and let them have a lot of pictures of the front of the microphone. Very valuable data. So we store that forever in 3 copies, just in case. Security is job 7, and I quit by 3. No, everything is secured. Everything is SSL. Not for Slack. Slack has their own issues. Fortunately, we're not putting any secure data in here. One thing I'm showing you is that data that I was storing in HDFS files, which was everything from that original call from the device. I put that in Parquet files in HDFS. You could see it now. Now it's a table that anyone in PySpark, Impala, or Hive can query and join these together. And then we got another one that's the statuses. That was the results of the job. Then we've got one for that first load. I had the other AI running. These are some of the other results, which there's some really funky names in there. I'm curious what it thought a jack-o'-lantern was. Red wine, I could see someone left something on a table, but I don't know what jack-o'-lantern was. And then the last part was some other data we had coming in. So that's a nice feature of this. You could also use it to explore your data, and it's all in a shared environment that's easy to set up. And again, for it to be buzzword compliant, it's in Kubernetes. Everything's a Docker image, and it's secure, and it's set up for your company to be able to look at that pretty straightforward. So that is one of the flows we do. Another one, which is, maybe not as fancy, but a lot of people like doing this, and this one I don't need a device, which this was going to be my backup if I couldn't get the device working, is just grab Twitter data. This is Twitter data about the conference. And this one's very trivial, but it shows you how easy these sort of things are. Again, we're storing the data there. As it comes in, I can look at it. The provenance data, which I said was very cool, is helpful because it shows me what I'm doing, how I connect to it. This is a lot of valuable data. In here, I set some attributes from that Twitter feed, plus all that metadata we're getting back from, okay, this is the URL I called. Is there a status code that has an error? Like any of this, I could do programmatic routing or filtering. So this is where people were asking, how do you handle all these weird errors? Here you've got any kind of error code, any error message, so I can react to that instantly. So if someone says, Tim, you're not handling an error, I did this for the talk in the morning because I found something I wasn't handling. So I just, I forgot about that. Let me add a new route. And in a few minutes, I'm adding a new error condition that I handle and I do something with it. So that's the power of the platform, that I could do that live, which is very helpful when you're doing something like data science or the data engineering side. I got data. I might not know what it looks like. The data scientist might not be able to tell me what it looks like. It could be from a database. It could be from a REST API that someone said, hey, this looks like valuable data. This is a government feed of data that I just found. Can you explore it? And as you're exploring the data, I could change this flow very iteratively with version control. So, as I get to something that looks good, let me commit that to version control. Andy, did you get to show them the changes? What's kind of cool with NiFi, which you won't see with other version control, it tells you when I move something. I move a box slightly. So when this saves the version, it doesn't just save, what changed. It changed if I move something around, if I added something. This is pretty cool. So when I bring this flow onto my page or someone else's, it doesn't change the formatting. Because, it would be nice if it cleaned up my formatting.
Snap to grid is in what.NET.
Really? We should play around with that, but probably not right now. Okay. But so that's a nice thing. So I've got to a point where I think this is a pretty good flow. I got it versioned. And, with my results, this is just to show you what I can do with that data. I can push it to S3, push it to Mongo for no reason, throw it away, push it to Slack. Whatever you want to do, you have that. And if there's errors, you can keep going. These flows go as far as you need to go. So as you're exploring the data, as you're looking through data sets that you might want to start doing models on, you could explore them, get them in a format you need, convert them from CSV or some text format. We've got the ability with Grok parsers to take apart log files very smart and very easily. I'm pulling the sudo logs. It's like one line of Grok, and it's pulling apart a sudo log so I can check it if someone logged in. And that's a flow I did for one of the stock exchanges. And now that's a very easy process for them to do. Oh, who tried to sudo on this box? If that happens, send an alert to this system. And that's like 3 boxes in NiFi. So you get the idea. You could do all that powerful processing while you're feeding the machine learning classes, helping you train them, and integrate that along the way. I did mention we do have unofficial deep learning libraries in here. I put 2 in there. These are very easy for you to write. They added a Java API. NiFi requires Java for these processors, so Scala kind of works too. So there's a Java interface to MXNet, and there's a Java interface to Tensorflow now. So I just took some Java Tensorflow API, wrote a small program, and now it's a processor. So if I take any Java code I have in my enterprise, I can just quickly wrap that in a NiFi processor, which you had that talk today?
It's at 4 or not today.
Yeah, that's where, if you're interested in that, come to that talk with Andy. He'll show you how easy it is to create one of these boxes yourself. And what's nice when you do that, you get all the features of NiFi. You get the ability for something to be in any flow and have all these features in it. You know, you make it something that's your code is now instantly distributed among multiple nodes. You could have multiple tasks. Now you could have the option of how you schedule it. Plus you get all the advantage of NiFi where you have built-in queuing before it, all the provenance data. So if you have a process you have now, or if you want to spin some MXNet or Java or DL4J code into a flow, you don't have to call out to Python, which I do sometimes. I switched it over to the Java API for Tensorflow and MXNet, and it's now maybe 20 times faster than calling out to a Python script, which is why I did it. So this one is the single shot detector for MXNet, and the other one is TensorFlow for Inception 4. These are in the public open source. These are not official parts of the project yet. But they've been working pretty stable, but it's a good reference architecture for you if, say, you have your own custom TensorFlow model. If you could rewrite that in Java, you could drop it in as a box here, and that makes it a very easy way for you to have real-time streaming going through calling your classification of a model. And as you saw, that was the one that was pushing back these different values as I'm pushing them for MXNet and TensorFlow. Let's see if we have any good slides left. Nope, we got through all the slides too. Does anyone have questions? Otherwise, I'll dive more into one side or the other. Are people more interested in the NiFi for the data engineering part or the CDSW part for, you know, team building of machine learning, deep learning models? We got people in the middle. They're like, CDSW? Yeah, we were supposed to have, we could dive into a little more on CDSW. We were supposed to have Tristan co-do the talk with me, and he would have probably spent more than half the time talking about this very cool tool. I mean, it's a nice way to organize your thing. So you have accounts set up for people, and you'll get resources you're allowed to do, and you set up projects. I set up a project for doing this, and it shows it all in one place. What's nice is I could show you, we'll build a new project, and let's call this project DWS. I'm going to make this public for all the people who have logged in. So now I have a new project. This is a workspace that I said anyone who's logged into the box can share this. Obviously, you could change what you want to do with that. It gives you some default files, which is a good way to start out. And it's got everything set up for me to start working. The first thing that I would do is I would go to the files, go into a file and then open a workbench. The workbench is your environment to run things. Yeah, I probably don't need a GPU for this. Someone might be mad if I take their GPU. So this is just an easy way for me to start exploring code. In the next version, there will be an auto connector for Jupyter and Zeppelin. So if you don't want to use this editor, which is not the fanciest editor, and we don't want it to be the fanciest editor, think of this exactly like GitHub. You might code in GitHub, but you're probably not coding at GitHub. This is really, okay, I've created my script somewhere in a notebook that you're comfortable with, and I think it's somewhere near where I want to share it with other people. I want to run experiments. I want to deploy a model. I want to build a job that's going to run. This is a good place to do it. For me, I like you give me any kind of API or any kind of tool, I'm going to use it as much as I can get away with using it. So, I mean, you can, like I said, I already have an environment. What's nice here, it also creates a shell on top of this Docker. So now I can do anything that I would do in Linux for that Docker container. So I get a command prompt, and I could do, here I could pip install whatever I need to install, and they give us by default, it's pip3 because I picked a 3. It's got Java on there. I've got a full environment to start interacting with. So to me, I like to have, it's pretty cool to me that I have a terminal access into that. But, from here, I could still do, I have access to my HDFS. So, you get some of those notebook features, especially for a data engineer that says, someone gave me this. Okay, let me see, what do they really want to talk to? Is that data exist? Does it have permissions? All those sort of things before I just start running it. And then once I say, okay, this class looks good, I could stop this session, save those resources for later. What's nice is that session's saved unless you want to delete it. So I can't remember how I got this working the other day because I said, it's quitting time. I'm not doing any more. The session's there. I could see all that, see what I did, and then remember, okay, that's what I meant to do. Let me do an experiment. Now, the experiment thing I thought was really cool. You pass in, makes more sense for people doing machine learning. What it is you run your script, which is, any of these types. It builds a Docker kernel for it, whichever one you pick, with the sizing. And when I run it, which I don't have any real experiments on this one. I have some over here. It'll run it, and every time it runs, it will collect all your features and say what the results are. So if you wanted to check, okay, which one is looking better, you could keep running these experiments. And then as someone gives you a new iteration of the algorithm, let me run it again. What's cool about that is not only does it run an experiment, if you come from the real world of science, this keeps the full log of it. So it's not, I ran some, how do you know what the results are? Someone wants to see the results of this algorithm versus the other one. And maybe there's regulations that say, how did you get to those results? And you're like, well, data scientists ran this a few hundred times. And you're like, well, what proof do you have of that? Well, I have the proof of that. I have the run session there, what build it was, and to make it even better, that's a redeployable Docker, so I can rerun that whole thing for them. So not only do I have the results of it, what were the results, how do they look, I can, run that again. Like if you look in here, let's go back to one of the experiments, this one. If I go into there, I could see what are the metrics, and you can export a whole bunch of metrics there. And you could output that as a model, and that model, that's a pickle for the Python people. I could just wrap that in a call, and now that's deployable. And then I could keep running these experiments as that iterates through. I could do it again, and you've got a full log of that. And the log, again, can be rerun at any time, besides having all that details. So as you're figuring out what your model should be, you've got a full run of that, which is really nice. And then you go from the experiment. You started off in a workbench, fooling around. You do some experiments, get to a point where you like it. You deploy it. Now it's running. It's been running a couple times. Now you could see the monitoring. You see what's going on, how many times it ran, all those sort of things with the full log there. That's a nice way to deploy this. And I can share this with other people on the team, who else has access to administer things and do, maybe someone else can work on a model with me. This is really good for an enterprise, and this ties in to the existing logins that you have in CDH or an HTTP. So can you reuse that whole thing? So that makes another way to do this pretty nice. You also have some standards so you can connect to SSL and, is this always public? Is this not public? One other thing is there's a couple of keys they put in there. So when you're running these models internally, if you don't have that key, you can't run it. And this could all be run over SSL. At some point, we'll wrap everything in Knox so that you have, full perimeter security. But for now, it's a pretty good way to run these models. And there's new features coming out very shortly, I've been told. But that's a nice set of things to do. Like I said, I like this. You know, I came from Hortonworks, so we had Zeppelin, which has some things I like, but being able to have a REST API, I had a couple clients who'd actually run real live Spark inside of Zeppelin as their runtime environment because they didn't want to do a Spark submit. This gives you something a little better than that, and you get the options to do experiments. You know, you could use the Workbench as a way to explore and code, but you have this full place where you can deploy a model for real world use. And since it's a REST API with JSON, that means I can put it in a mobile app, I can put it in a website, I can ingest that in NiFi and maybe another group's NiFi. You know, the data science team is hosting it, but another team is using it. And you could do that with other things that might be a Python REST API you might want to share, whether it's a machine learning model or just a simple Python function. Doesn't have to be a machine learning or deep learning model, but that's just something you could do. And it also hosts R, so if you have any of those, you could do it right there. Simple tool. I think I learned it in a day. I don't think it's that hard, which is very nice. You could give these tools to any data scientist or data engineer, and now you've got a way to deploy models, test Python code, do PySpark, do queries. There's connections so I can hit Hive tables or Impala tables. It makes it a nice little dashboard. For people coming from the Hortonworks world, we had some other tools to do that, and so did Cloudera. So there's thought maybe Hue and some of the other tools will all come together, but right now there's a couple tools to do this. Pretty straightforward. If anyone's interested who doesn't have it yet, you can go to the Cloudera booth and you can get a free trial license for this if you want to try it out. And, you know, it's a fun thing to explore. There's not a lot of heavy lifting in there. Installs a separate Kubernetes cluster. So you can put this on some like 3 edge nodes, have it run there and try it out. Try it maybe locally with none of your data, or you could, you know, feed some of your data in there, or you can open the pipe up. If you look over here, this is the cluster that it's connected to. This is a regular HTTP cluster. So that's how I can get access to it. I get full access to the Embari, so I can see, you know, Hadoop. Obviously, you got to have admin permissions and all that. But this is where I'm getting those HDFS files from, is from that connected cluster. And you could connect it to your cluster or not, depending on if you want to share that data, especially when you're doing a POC. Are we out of time?
We are.
Okay, thank you.
Thank you very much. Sorry.
No problem.
Sorry, guys. We have the next one coming in.
No problem. Oh, I got to shut things down.